Okay. Hello, everyone. My name is Taylor Williams, and I am studying turfgrass management under the Plant Sciences Department. As a whole, my art experiences were very beneficial to my research project, even with the extremely steep learning curve I experienced. I did not even begin to grasp the art techniques until about halfway through the semester, but with a little practice and effort every single day, things in art began to fall in place the more I played around with it. Our research project deals with performance testing on Bermuda grass athletic fields using different testing devices to show how the safety characteristics and surface hardness values of a football field change over the course of an entire season. So here's my Forestry, Wildlife, and Fisheries 525 webinar. Here are the three functions or qualities an athletic field must have. The athletic field must provide a safe playing surface, meaning the field must be soft, which reduces the risk of having a concussion, but not too soft when traction begins to reduce as cleats are unable to grab the turf surface properly. Playability refers to a consistent playing surface, free from humps, divots, rocks, or anything else that might make the athlete uncomfortable while playing a game or during practice. Aesthetic appeal comes last because it is the least important of the three factors. A field will look nice if proper management practices have been carried out during a season. A field must be mowed, watered, and fertilized in order to be visually pleasing. Here are three common turf problems that I must deal with for my research experiment: compaction, an unsafe playing surface, and a loss of turf coverage. This picture is a good representation of what soil compaction looks like. The plant on the left is able to grow properly because its roots can freely move throughout the soil, and the picture on the right shows a good example of what happens when the soil has been compacted. There is a loss of micro and macro space, leading to limited growth for the plant. The roots are unable to penetrate through the soil profile in search of its nutrients, which leads to the plant not growing at its highest potential. Loss of turf coverage is also an important issue of managing an athletic field. Players over time constantly remove leaf material with their cleats and compact the soil at the same time. And this loss of turf coverage eliminates any cushion the turfgrass canopy might supply for a resulting fall. Here's a picture of the device known as the F1292 or E-missile. This device is used in my research to measure surface hardness by dropping a head-shaped missile to the surface from three various heights football players might fall from during a practice. This device outputs a head impact criterion or HIC value. Any HIC value over 1,000 makes it 16% more likely a traumatic head injury will occur. However, there is not a football standard for this procedure yet. My research is trying to determine at which game during a season the field becomes unsafe for players. And my three drop heights were 1.3 meters, 1.9 meters, and 2.5 meters. The picture on the left shows what is known as a trafficker. It is just an aerator that has been modified to simulate cleat traffic to the grass surface. Okay, here on the left are 6 molded feet with cleats attached to the bottom to mimic the bottom surface of a football cleat. These 6 feet strike the surface over and over as the aerator or trafficker moves across the ground. As you can see, the picture on the right shows what happens as a result of 40 simulated traffic events. And one traffic event is just a pass down the strip, and then a pass back would equal 2 passes total. Yes, the grass is thinned, but also the soil underneath has become extremely compacted over this time. However, it is common in East Tennessee to see a high school or a municipal field that will still allow games to occur, even in this rough condition. I believe it is a field manager's job to have the knowledge and tools needed to shut down a field until it becomes safe and playable again. the trafficker is designed to put down 57 cleat marks per square foot. A grad student from a different university, thankfully, had to watch several football games in slow motion to count the number of steps between the 40-yard lines and between the hashes, as this is where most of the play happens during a game. For my research experiment, I used a randomized complete block design. This is the standard design for agricultural experiments, where similar experimental units are grouped into blocks or replicates. An RCB design is used to control any spatial effect that might affect the data. An example might be maybe one side of the plot does not drain as well as the other and contains a higher moisture value than the other side. The treatments are assigned at random for each block, and then there is only one treatment repetition for each block. Okay, here is my randomized complete block design. One of my research plots, I have two right now, but this is just the first one I did. Starting at a treatment of 0 games here, and then I stake my way back around to 40 games of traffic. There is a total of 18 subplots in my entire plot, so each block consists of 6 treatments, totaling room, or that means I have room for 3 replications in this plot. The other 2 blocks have been randomized instead of being in order in the same way as my first block goes from 0 to 40 games. Here is a series of pictures showing the results of traffic at 3 stages of my research experiment. As you can see, it does not take long for the grass to change color and eventually become unsafe due to compaction. Critical fall height is the minimum fall height an athlete can fall from, where the Hick values reach 1,000. As you can see, over a full football season, the critical fall height becomes lower and lower as a result of increased surface hardness. Roots provide a safe playing surface that is stable for the athletes. Long roots, as in the picture on the right, are essential to the safety of an athletic field. Slippage is reduced greatly with long roots, as well as the reduction of surface hardness. Generally, long roots show compaction levels are not very severe. Alright, so let's finally jump to RStudio. I computed a summary of my data, and you can see my maximum Hick value is 1612, which failed the safety test tremendously. If the same test was conducted on artificial turf, however, the critical fall height would have been much, much lower. Natural grass has always been the benchmark for athletic fields, as long as synthetic turf fields have been in existence. Alright. So I let R give me an ANOVA table for my data to show the significance of drop height and games of traffic separately. An analysis of variance is just a collection of statistical models used to analyze the differences among group means and their associated procedures developed by Ronald Fisher. Here's my first ANOVA table to show if the number of games trafficked and the resulting Hick value was significant. My p-value over here shows less than 0.05, making the number of games I trafficked significant. This was expected due to the effect of the trafficker on the turf surface. Alright, so here's my second ANOVA table for the effect of drop height and the resulting Hick values. As you can see, the drop height is definitely significant, as the p-value is extremely small. Okay, let me pull up R and demonstrate how my ANOVAs were input into RStudio. Okay, here is all my data, games, height, and Hick. I have 162 values, I believe, or 162 tests that I performed at 3 different heights. So, to run an ANOVA, you have to first fit a model, which I did right here in these two lines. So just copied and pasted my data into there, and then typed the R code for summary ANOVA. So I'll go ahead and do that. And here is the ANOVA for height. And for this one, you just have to do the same thing. And here's the ANOVA for the number of games trafficked. Okay, let me jump back to my PowerPoint. I also chose to do a pairwise t-test to show the comparisons between my group levels with corrections for multiple testing. I also used the Bonferroni adjustment method to adjust p-values because more than one statistical test is being performed on my dataset. Let me jump back to R and show the process of a pairwise t-test. So to do a pairwise t-test, I had to review the video several times, but I found it, and just type in this long code, your hic values versus your games. Then adjustment method is Bonferroni, so just enter that, and here are your p-values, and you can see some are significant, as in this row, and then others are not, as in the other 3 rows. Now I would like to thank Dr. John Zobel for his dedication to teaching R. It is a difficult subject to learn, but Dr. Zobel did a great job exposing me to the basic principles and uses of R. I would also like to thank the farm crew at the East Tennessee Research and Education Center for allowing the Center for Athletic Field Safety to be built, because all of my research is conducted here. And here are just a few of my image references. Alright, thank you.